Hey guys, today I'm going to be showing you how to do this nice and detailed exterior that we now have a lot of controls for. So we can have a unique first floor, as you can see. We can also just turn that unique first floor off. We can just have the same floor in every single setup. We can have a unique design on every certain floor. So currently it is set to be the second floor to be unique. If I could change this, I want to have it every third floor. So now every third floor will have this unique design, as you can see. We can change that. We can also offset it. So if I want to move that unique design up or down, you can see it is now moved down one. I can move it down in another one. So now I can have the unique design here. We also have the balconies randomly placed around. And if I want to, I can have them be in perfect columns. So I can have a nice column of balconies here on a switch as well. So lots of different controls that we're adding in today, all for exterior decorations. Let's get into it. What I want to do is change how we're actually copying this floor all the way up. So I want to have control over the first floor, and I want to be able to have a unique floor every certain amount of floors, and I want to be able to select a specific floor anywhere there to make unique if I wanted to. So for example, if you had a 20-floor building, you could have every other floor be a different design. And if you want to have like a unique floor in the middle that is different from all of them, you can specifically select that floor and then say that one is going to be something else. So I want to have that control. And of course, I want to have a different option for the base floor as well. So we're going to have all of that stuff in one node that is going to copy it, give us the difference in values that we can then isolate different sections from it if needed, and it's all going to come together. So with that, let's make our custom node that will take care of all of this. Go ahead and open up your PCG graph, and I'm going to just grab an execute blueprint and just drag it down here, select a random element, and just navigate to the actual location. Once I navigate to it, I'll go to BP elements because it has opened up the correct location, and I can delete this guy. Because as always, I'm going to grab our set point color as our base, and I'm going to duplicate it. I'm just going to call it multi-floor because this is going to be our multi-floor setup, and I'm going to move it into our PCG folder like so. Now let's go ahead and open it up. So here we are in our new node. We're going to clean this up a little bit. So under class defaults, category, we'll change that from color to custom. We're replacing all of our nodes. Then I'm going to delete the point loop body. We don't need that. We don't need the linear color. Delete that and open the execute with context. We're going to delete some stuff out of here. We're going to remove the point loop, the target actor, and the set. Get rid of all of that. Instead of this in context going all the way across, I'm just going to right click, get in context. And I'm going to just plug that in to make that nice and organized. And I'm going to move this over, and then I'm going to move this guy out of the way. And I'm also going to set local variables for tags and pins. So I'm going to right click, convert to local variable, call this tags and pin, just like it is here. So that way I can set them right before this cast node, and I can plug these in over here. So that way, if there are any tags or pins, everything gets propagated all the way to the end. From here, I'm going to go ahead and right click on this point data with context. I'm going to convert it to a local variable, and this is going to be just PCG point data. And then from here, we can go ahead and get points. And this is the plural points. And I can right click and promote this to regular variable, and I'm going to call it PCG points. So this is an array with all of our points. The only thing actually left to do is to go into our node title override, double click that, and change our node name. So this is the name that appears when you drag it in. So I'm going to call it multi-floor. Let's go back to execute with context, and now we can begin our graph. First thing we need to do is check if the amount of floors is greater than 1. Because if the number of floors is 1, we don't need to do anything. We don't need to extend anything. We can just keep things as they are if there's only 1 floor. So let's go ahead and make a global variable. I'm going to just call it floors. And this is going to be an integer, and it's going to be exposed because we're going to be able to plug this in. And in here, I'm going to set the default to be 1. And I'm going to make the slider range minimum and maximum to also be 1. That way we can never have a 0 or negative floor amount. So we can go ahead and grab that. By holding control, automatically get a get node. And then I need to check if it's greater than 1. And assuming that it is greater than 1, then we go ahead and actually do all of our stuff. But if it's less than 1, we can pretty much exit out of here. So to exit out, what we're going to do is take our make PCG tag data. And what we need to do is get our point data. And this is going to go into our make PCG tag data. And it is also going to set points. And the points are the points that we got. So from false, it's going to go into set points. And then it's going to go into this add node. And that is pretty much our execution area. Okay, so now the false is done. Let's go ahead and make the true. Let's get our PCG points and do a for each loop, because we need to go through every single point and check and set them accordingly. I'm also going to duplicate this PCG points and do a set array element. And if I drag out from item, I can do set members. If I just search set, it automatically pops up. So I'll get the set members node, plug this in, and I'll plug in our array element into struct_ref and our array index into index. And now I have kind of our base set up all complete. So now we can do everything we need kind of in between these nodes. So similar to how I've done it in the past, I'm going to take these points, I'm going to save them to a new array. I'm going to move that array up, and then I'm going to modify it, save that array, move it up, save that array, move it up. And in the end, basically, I'm going to have a new array that is the original, these PCG points, that is just going to be the top layer wherever it is. And then a new array that I've been saving things to that has everything else. And then I just combine them together, and that is then our output. That is the way that I found that seems to work pretty well and doesn't get any hiccups. So that's what we're going to be doing on this one as well. So I'll go ahead and make a new local variable, and this is going to be our PCG points collection. The type is going to be PCG points, and it is going to be an array. So from this loop body, we can go ahead and grab our PCG points, and we can grab ourselves an add node. For each of these points, it is going to add itself, and then it is going to do something. So in our case, we need to actually transform it upwards. Let's go ahead and split this transform, and let's get our array element and break that and split our transform from here. So our rotation is going to be staying the same. Our scale is going to be the same, but our location is going to change. Let's go ahead and split our location. Split it from one and the other. So X is going to be in X, Y is going to be in Y, Z is going to be changed. So we're going to go ahead and add, and you can plug the add node in. And what we're adding is the height. So let's make a new variable, and this is going to be our floor height. It is going to be a float, and is going to be a regular single, and is going to be exposed. I'll compile it so I can set the default to 300, and I'll make the minimum something like 10, just so we can never go truly to 0. And then I'll go ahead and grab that floor height and plug this in. It is storing the current points in this location, then it is going to move the points up based on our height, and then it is going to store those locations. So if we ever to go back to this loop, it will once again store them into our collection, move them up, and repeat. But I also want to, of course, be able to now also select a unique point, or rather a unique line going upwards. So maybe I want to select floor 5, floor 6. So the way I thought a decent way to do that is if you start off with everything at 1.0, right? That's what we kind of have as a base. And then instead of moving it up and just keeping it at 1, what if we slowly removed a little bit from each one? What we're going to do is take our 1, and then we're going to subtract 0.01. So now it's going to be 0.99, 0.98. 0.97, 0.96. And so by having it just a little bit different in value, you can then go and use a density filter to filter out a specific floor if you wanted to. To do that is relatively easy. We take our density, we subtract 0.01, and then we plug that into the density by selecting the set members node and exposing density. We can just plug that in here. Every time it is going to add the current value, and then the next one, it will actually be 0.01 lower, which is exactly what we want. Now this is all great and all, but I want to also now have a way of separating out the first floor. Let's make a new variable, and we're going to call it just unique first floor. And this is going to be a bool that is exposed, and this is going to be off by default. So this unique first floor is going to be our check to see if we want to have a different floor on the first one. Let's go ahead and grab our unique first floor, and I'm going to basically modify this PCG points collection when we go through it if it is the first floor. So we need to check if this and something else is correct. So if it is unique first floor and it is the first time it is going through this list, let's go ahead and then execute something. So for that, let's get a way of checking how many times we've gone through this loop. So for that, let's make ourselves a new local variable. And I'm going to just call it floors completed. For us, it's going to be an integer. And if I compile this, I'm going to set the floors completed default to be 1. Now, the reason it is 1 and not 0 is because if it is on the first floor, it is going to be exited out. And when it's going into this loop, the first time it's in here, it already has the first floor information. So it has technically already completed first floor. I'm going to take our floors completed, and we're going to check if it is actually equal to 1. So if it is the first floor, and we have said that it is going to be a unique first floor, then we can go ahead and use this information. What we're going to do is grab out of this add node, and I'm going to do the same thing, set members as we have done here. And I'm going to just relink this in between, plug in our array element into our struct ref, and then we're going to expose density. With our density, I'll go ahead and grab ourselves a select float, and our new Boolean is going to go into our pick A option. Assuming that it is the first floor, it is going to pick A. So by default, it is going to grab our density into B. So let's go ahead and take all this, and let's just move all of this to the right, because we're going to need a lot more room here. As you can see, it is getting quite spaghetti-like. Assuming that it is indeed the first floor, the floor is completed, I'm going to just set the value to 0.05. That way I can filter between 0.0 and 0.1. Very easy to filter. It'll be right in between. And our first floor will be unique. Excellent. Now, of course, once it has completed a floor, we need to increment this. So I'll go ahead and grab our floors completed, and I'm going to search increment or ++. And when it completes it, it'll increment this value so that only the first time it has done this will it actually ever set that floor to be 0.05. Now, at this point, we just need to check if the amount of floors is actually the same as the floors completed. Because if it is not the same, if it is not equal, that means we still need to do this loop a few more times. So we'll go ahead and grab ourselves a branch. And then if it is true, so if the amount of completed floors and the amount of floors we're doing is not equal, let's go ahead and redo this loop again. But if it is the same, but if it is indeed false, that means it has completed all the loops. That means we can go ahead and save this all together. So let's go to our PCG points collection and do a for each loop and plug this in from our false. And all it's going to do is add itself back onto the original loop. So there we go. Our PCG points then just get repopulated with our PCG points collection. And once it is complete, we can actually just exit out of here. So from our completed, we can plug this into our set points. But there we go. That is the basic setup, right? It is going to make the first floor unique. It is going to copy things upwards. Seems like we're good. Let's go ahead and try this out already. Let's open up our PCG building, and I'm going to take our multi-floor node. And if I just drag it in here, you can see there's our node, multi-floor. And I'm going to take our merge node from here, and I'm going to plug this in into our multi-floor. And then from here, let's go ahead and open this up and plug in our floors. So I'm going to just right click and get actor property. And I'm going to plug our property name of floors into here and then plug this in. Because as you recall, our blueprint has the variable floors exposed right here. We can set the amount of floors. Our floor height is hard-coded for now, and unique first floor, I'll go ahead and check this on to be true. So if I go ahead and sample this, and then I go ahead and just rebuild this, you can see it has now copied the point upwards exactly where we had it. And you can see down below, it is actually a darker value. So now we can filter out this point. Now this might look all the same value, but if I come here and I get myself a density filter and I stop sampling the multi-floor and plug this in, so in the density filter, what I can now do is filter out, let's say, like between 0.98 and 0.981. Now, the reason I'm adding just an extra 1 here is sometimes I've noticed that if you do exactly 0.98 or exactly the value, it's a little bit iffy on that. So I can filter out just a little bit of a tiny range there, and I can sample it. And if I go ahead and rebuild it, you can see it has now selected the third floor. So if I sample now 0.92 to 0.921, you can see it has now selected that floor. And of course, we can do the range as you saw. So if I did to 0.95, so we can select unique ranges. So we can filter out, no matter how tall the building is, we can specify certain floors of this building to be unique, which is not necessary, sure, but I like the ability to do that. And it's no extra work on the node really to accomplish this, because it's just an extra little subtraction, and you just got to keep that in mind. And of course, if I want to, I can go ahead and filter between 0 and 0.1, and now I have the unique first floor. So you can see all the points on the first floor have been selected. So I'll go ahead and stop sampling this, and I'll unhook it, and let's go back to our graph, and let's add the rest of the controls. And if this tutorial is helpful to you guys so far, I would appreciate if you hit the like button and subscribe if you haven't, but let's get back into it. So this is all working lovely, but the next thing we need to actually set up is the ability to make unique floors every X amount of floors. Because right now it's all the same style. And I can specify a unique specific floor, but I don't want a specific floor. I want to just say every other floor be unique, or every third floor, or every fourth floor, and just take that and proceduralize it as much as I can, because filtering for unique floors is kind of too much work. Let's make it easier. So for that, we're going to need a few variables. Let's start with a simple variable. I'm calling it unique design every X floor. It is not a great name, but if you have suggestions on better names for this, I'll take it. I'm not great with coming up with good names, but it is going to be an exposed Boolean. And basically, if you have it on, then it is going to select a random floor to be unique. Otherwise, it is going to be as we have it right now. What we need to do is take this and we're going to check if this is on, and the same way we did the area right below it, where we checked it and its parameters, we're going to do the same thing here. So what we need to do is take our number of floors and we need to check if it is the third floor, the fourth floor, etc., based on your input. So we need a new variable, and in this variable, X floor variations, and this is going to be an integer and is going to be exposed. The default for this will be 2, and the slider and value range minimum is going to be 2 for both. And the reason for that is we don't want this to be 1 because it doesn't make sense to be 1, because if it is 1, that is not unique design every X floor. It is just the original design on every floor. And of course, we can't have 0, so 2 is really the minimum that this would ever be. So to get this set up, what we need to do is grab our floors completed, and we need to grab ourselves a modulo. So if you can search modulo, you can search the %, that'll get the same result, and you get this modulo a %b. It takes your input, it divides it by the number, and you get the remainder. So if the amount of floors is 3 and this was at 2, the remainder would be 1. If the amount of floors is 4 and this is 2, the remainder would be 0, because 4 divides into 2 evenly. But what we can do is, instead of having this hard-coded, we have X floor variations. So this way, we check if the amount of floors completed is correct relative to every other floor that we want broken up. So if it is 0, that means there's no remainder, in which case that means it is actually going to be the third floor, fourth floor, etc., that we have specified in our X floor variations. So I'll go ahead and plug that into our AND node. And what I'm going to do is grab from this select float and I'll make a new select float. So we're going to have kind of an in-between section here. So I'll take this and just move it out of the way. So this AND node is going to grow right in here. And then we're going to take our density. Our density is going to go right into the B of this, because again, if it is not this and it is not this, that means it is going to be the default. But if it is indeed this unique floor, we want to have it changed. The way we're going to break it up is by taking our density, and I'm going to just subtract 0.5 and have that be the A. So effectively, what it's going to do is, if it is a unique floor, then please subtract 0.5. So instead of 1, it'll be 0.5. Instead of 0.9, it'll be 0.4. And that way, every third floor would just be a little bit lower. Now, of course, this entire system means it is designed where it can never be like over 99 floors, because at a certain point, you're going to the negatives in values. Every unique floor is minus 0.5, then right, you have a limit to the skyscraper you can make. So if you wanted to make a setup where you had hundreds of floors, you will have to tweak this. But for most scenarios where you don't have absolutely gigantic skyscrapers, this will work. Now, once this is done, it has gone through everything. So if I go back to our PCG building, and I'll go ahead and re-plug in our merge node right in here into our multi-floor, and I will change the unique design of our X floor. I'll turn that on, and I'll go ahead and sample it. And then if I just rebuild, you could see already we're now getting the unique first floor. So we have 0.5, 1.5, 1.5, 1.5, 1. And the reason we have a problem here at the top floor is because currently our setup is going through everything and checks the number of floors completed in itself. So it increments here. It doesn't increment here. What we need to do is check after this is completed if it is actually needs to modify that very last floor before it re-adds it to everything together. So what I'm going to do is I'm going to take all of this, these floors completed X variations, take all of this. I'm going to duplicate down here and just check that this is now correct. After it is done this check, it has now realized this is the last floor, which is great. So it's done that check for us. I'll take all of this and just scooch it down. If this needs to be actually a unique floor, then let's go ahead and make it so. And I'll just duplicate our PCG points and our loop here, duplicate it over, and I'll take our set array element and set members and just duplicate that as well. Now we're not going to be changing our transforms for this. We are going to be changing our density. So from this false, we can plug this into our branch. If the branch is true, it goes into this loop. If it's false, it goes into here. All we need to do is plug all of these together, break our array element to get our density, and we just need to subtract 0.5 and plug that into our density. Again, array element goes into struct ref, array index goes into index, and that's all we need to do. And once this is complete, it goes back and re-adds itself correctly into the rest of the loop. So now if I compile and save this, and we check out our building and go ahead and rebuild this, you can see now it is correct on every other floor. Now, what if we wanted to change this, right? We can go ahead and go into this setup, and I want to have a variation every third floor, right? I go ahead and change this, rebuild it, and now you can see it is every third floor, but there's a slight problem. Because it's every third floor, right? We have our unique base, a unique level 1 floor, then we have a 0.5, 2 1s, and a 0.5. But it's not 2 gaps in between on the beginning, on the lower section. We want to also be able to offset this. So I want to be able to specify, I want to move it up or down. So that way, when in cases like this, where it doesn't quite line up because I am using a unique floor, because if I wasn't using a unique floor, if I turn off the unique floor and recalculate, this is correct. But if I am using a unique floor, I want to specify, go ahead and move it up a level. To do that is pretty simple. Let's go ahead and open our graph up. And all we need to do is grab ourselves a new variable and just call it unique floor offset. It is going to be an exposed integer. And all we need to do is take our floors completed and subtract our unique floor offset before it's going into this modulo. And of course, we do the same thing over here. Before it goes into our modulo, it is going to go into the subtract node, just like that. So now if I compile and save this and we go back to our setup, it is all correct, but now we can go in here into our multi-floor graph and I can specify a unique floor offset and specify 1. When I specify 1 and I recalculate it, you can see it has now moved it upwards. So now we have the correct setup where we have the base black, 2 1s, 0.5, 2 1s, 0.5, 2 1s, 0.5, and everything is as it should be. Now, if you're following along, but you have some questions, you can drop by the Discord and we can help you out there. Or if you want to compare what you have done to the original files, these files, as always, are available on my Patreon, and you can join these lovely people here in supporting me and what I do, as well as getting access to all the project files after every tutorial. Thank you so much to these lovely individuals for supporting me. Let's get back to the tutorial. So that is it for this node. It's actually a relatively simple one. Let's go ahead and start using this node and replace a bunch of our stuff in our graph to start using it. So let's go ahead and take this information and we can remove this density filter. We don't need it. That was just for demonstration. We can stop sampling this. So we can go ahead and change this up a little bit. So I'm going to detach this merge node because this is going to go in here and we're going to be changing up some stuff here. So let's go ahead and delete this copy nodes. We're no longer going to be copying these nodes. We don't need this single floor Boolean. That is no longer needed. I'll go ahead and detach the transform points here and I'll plug this in. So it's going to go from our multi-floor setup into our offset. And as you recall, all this is it's offsetting the pivot of the objects. Our current walls have the pivot in the corner and we want to just center it. That's all we're doing with this one. Yeah, from here, we can go ahead and remove this floor copy offsets. We're not going to need that anymore. And I'll go ahead and just clear this off, detach these, and let's go ahead and do our first floor doors. So from here, I'm going to get a density filter. And as you recall, we already filtered out our first floor to be 0.05. So I'll just filter between 0 and 0.1, and I'll plug that into our select random points node. So effectively, we got the same result, but we're just now filtering out that first floor and we're taking our random points from there. Then we need to get a difference node and we need to filter out the rest of the floors, right? So we take our density filter that we just made, and we plug that into our difference, and the original points are going to go into the source. So all this is we now have a version of the original that has everything, just the first floor, and then everything except the first floor. So I'm going to go ahead and get rid of this difference node because it's already been filtered out. And I can take this density filter and plug this straight in. So we actually don't need this 2 points. I'm going to hold control and just drag this in and plug it all the way through. Go ahead and remove this 2 points. I'm going to change this density filter to be from 0.01 to 1. Effectively, it's everything that is outside of the 0 to 1 range. If I set 0, it does have some issues I found, so just a little bit higher than that. If I come here and I rebuild this, you can see our doors are now back. That is now working correctly. So we can take the points that we have now taken from here, use them as the difference compared to the originals. When it is this value, this is our unique first floor. In our static mesh spawner, I'm actually going to take this, I'm going to duplicate it so I have a copy of this below. But in this version, I'm going to change this to be our unique wall piece. So I've gone ahead and got myself a few more Megascans assets. So I have this base wall that I'm going to be using for Megascans. I can plug this in. And in my case, I need to slightly transform this. So I'm going to take a transform node and I'm going to just plug this right in between the two. All I'm going to do is modify the pivot of this. So I'm going to change this on -50 in the X, 10 in the Y, and it's going to be for minimum and maximum. And I'm also going to turn off uniform scale and I'm going to scale it vertically by 0.75. And again, this is purely because these are not all the same scale of values between all the different modular pieces that I'm using. So I'm adjusting for it. But once that is scaled, I can go ahead and rebuild it. And you can see we have now made a unique first floor here. So when it is a unique first floor, it is going to use this piece and I can rebuild it. And you can see it is now putting doors in between the pieces and it is a unique first floor. Excellent. So now let's take this and use it for when it is not a unique first floor. From here, I can go ahead and grab myself a couple of density filters. The first one is going to be between 0 and 0.5. And the second one will be between 0.5 and 1. So the 0 to 0.5 one is going to be our new unique piece. And the bottom one, the 0.5 to 1, is going to be our original. So because it's our original, I can go ahead and hold Control and just plug these in. So I can just do this right here. And then for our unique new piece, I'll go ahead and duplicate this and I'll plug in the density filter into both of these nodes. I'm going to change my static mesh to be something else. So I have a slightly varied window that I can use here. So I'll go ahead and plug this in. And if I go ahead and rebuild this, you can see the unique floor every fourth one. So if I go into our node here, into our multi-floor, I could specify our floor variation. So I can specify 2 and then rebuild it. And now you can see it is every second one is this unique one. Now let's go ahead and expose these into our blueprint so we can control it from the get-go. So I'm going to press Control B to navigate to that location. And let's go ahead and add some variables. Let's first make some bools. So we're going to say unique floor breakup. And we're going to also have one that's going to be a unique first floor. Both of these, of course, are going to be exposed. And then we're going to need to get a unique design every X floor. And that is going to be an integer. And a unique floor offset, also an integer. Everything is going to be exposed. The unique design every X floor is going to be by default 2 with a minimum on slider and value to be 2 as we did in our graph before. Our unique floor offset by default will be 0. And it can go positive and negative. That doesn't matter to us. And now going into our PCG graph, I can go ahead and expose all this stuff, open up our multi-floor. And then from here, I can just get our actor property. I'm just going to duplicate this over. And I can go ahead and just copy the names from this. So I'm going to select our unique floor breakup, go ahead and copy, plug this into property name, set of floors, and plug this into unique design every X floor. And once it's all plugged in, go ahead and collapse this back up, save all that, and then rebuild this. And you can see it is back to normal. But if I turn on unique floor breakup and recalculate it, you can see our unique floor has returned. And if I turn on unique first floor, our unique first floor is back. Give ourselves an offset. There's our offset back. So everything here is working wonderfully. There's only one last thing that I want to add, and that is just I want to add some balconies because it's just a little bit too plain still. Let's go ahead and just add some balconies into these simple versions. So that way, when we have a unique floor every third, let's say, we have some more interesting stuff going on here. And to do that is very simple. I can use the static mesh spawners right here to go ahead and just select random points. So I'm going to get a transform points nodes because I need to modify the pivot. I know that already. And this is going to be off of our default regular walls. So from there, I'm going to take that and then I'm going to grab myself a select points node. And this is just going to select a random amount of points. Now, of course, you can specify the unique amount of points with a select random points node, but I'm fine with a random amount of points and we're going to just specify 0.35. Select 35% of all the points. And then I'm going to grab myself a static mesh spawner, just duplicate an existing one. And then here, I'm going to just plug in a new balcony. So I have a balcony that I grabbed off Megascans as always, plug this in. And for my balcony that I'm using in the transform points, I'm going to set the offsets to be 35 in X for both minimum and the maximum. So you could see, well, it has a unique setup every time, but it is copying that balcony upwards every single time. If I turn on recompute seed here on this transform points node, it is now completely random. But if I turn it off, then it is pillars. So that is something I can actually expose in our blueprint. So let's go ahead and make a new Boolean here. And I'm going to call it column balconies, make it exposed. And here in our transform points, I can go ahead and open it up and I can go ahead and grab one of our get active property nodes. And I'm going to take our column balconies and copy it, paste the property in here. And actually, instead of column balconies, I'm going to change the name to random balconies. Because by default, when it is off, it is going to be columns, but when it is on, it is going to be random. So this makes more sense. And of course, update the name here. And I'm going to plug this into recompute seed. So now if I go ahead and check this out, we have our columns. And if I turn on this checkbox, you can see it has now randomized it. And this one does get updated automatically. So you can see we can either have perfect columns, or we can go ahead and randomize it. And it's only applying it on the areas where we have the original setup. So if you wanted to have this on everywhere, if you want to have just full columns, you could. You would just not have it come from here. You would have it come from the original before we split it. So if I want to, I can just take this instead of from here, I can plug it in right in here. And this is going to be on everything. And I can turn off this checkbox. And you can see now the balconies are the entire length instead of just in those sections. Now, in my case, I'd rather have it just be in those areas. I think it looks more interesting. And I'll turn on the randomizing, and there you go. So this is now a lot more interesting. The only thing that I have left to do is just a simple fix. And that is if I set the floors to 1 and I rebuild it, you can see we have a lot of stairs in here. And this is just a simple fix that we can take care of right now. If I go back to our PCG graph, we just need to modify this 2 adjacent points that we have made before. So I can go ahead and double click it to open it up. All this is that's needed is from here, from our check, that if the floors is greater than 1, if it is false, then we exit out of here. But before we exit out of here, we just want to set all the points to be 0. We just want to do what this is doing. I'm going to take this, I'm going to duplicate it. I'm going to just put it right above. And instead of going to set points first, it's going to go into this for each loop, and then is going to go into the complete. So effectively, it's going to go through all of the points and set them all to 0 if it is one single floor. So go ahead and compile and save this. And now if I just rebuild this, you can see now we have our first floor all correct. Now we still get balconies on the first floor because it is only one floor. That is something that we can still adjust in the future to remove it from the first floor. If I have multiple floors, you can see we now have our unique floor. We have balconies. We could specify a different setup here, and there you go. So just like that, this is a whole lot more interesting. And one final thing, just for cleanup sakes, let's go ahead and just modify this section, right? We still are using this in one other location, and that is here, this floor ceiling section. So let's go ahead and just reuse this multi-floor. Now, something I have noticed is if I take this multi-floor and just duplicate it over, and for this new one that we're going to be placing right here, if I turn off unique first floor and unique floors every level, because we don't need those, and I'm going to just grab our floors variable and plug in our floors. If I have the same spline sampler, and I plug this in here, and I sample it, and I rebuild it, you could see it has placed the floors all the way up. And I'm not sure why this is. If I take the spline sampler and just duplicate it, so it has the exact same properties, it has the same inputs, nothing has changed. And instead of it going from this original one, but if it takes it from this spline sampler, you can see now it is all correct. So I'm not sure why that is, but all we need to do is, as you see, duplicate the spline sampler with the get spline data and the actor property. And now we can use this in here. From here, we can go ahead and delete this copy points. We don't need it. We're now going to need our floor copy offset. Let's take our difference node, and this is where we're going to plug in our multi-floor right into the source. Our difference is still going to be the same. Our floor offset is for the pivots, and the scale is all the same. That should now, if I rebuild this, get us the same result as we had before, and go ahead and stop sampling it. But now you can see the result is the same. We still have our floors every level, but now we can go in here and just delete all of this because we no longer need it, because we are now taking care of it using this one new node. Yeah, I just want to point out that for some reason, sometimes taking the information from the same node, even though the result is the same, does not yield the same results. So maybe that seems to be a bug. I'm not sure if it's a 5.3 or 5.2 bug, but now we don't need that information, and we can do some more cleanup later down the line. But for now, this gets us a pretty nice result. But that's it for now. Thank you guys so much for watching. I'll see you next time. Take care. Bye.